So probabilities, like I said, we're going to look at, those are what we call experimental probabilities. And most of what we're going to be dealing with in this class are experimental probabilities. There's also theoretical probabilities where you actually just calculate the probability of something happening based on what you just know of the idea of it happening. So let's say I roll a die, and you can put in the chat what you think. What's the probability of getting a 3 when you roll one die?
One out of 6.
1 out of 6, exactly. And you know that that's 1 out of 6 because you can get a 3 one way, and there are 6 sides on a die. So there's 6 outcomes in your sample space. So every probability, every example we do has a what we call a sample space, which is a listing of every possible outcome that can possibly happen. So when I roll a die, I can get 1, 2, 3, 4, 5, or 6. So that's my sample space because I'm listing out all the different ways they can happen. On this previous example, my sample space would be all of the different items that could happen, my axis, my big, my confer, all those different things that could happen. That would be my sample space. Here, my sample space is a listing of all the different sides that can happen. Now, this one we did over here, these are known as experimental probabilities because we're actually experimenting and calculating what they are. Again, experimental probabilities are where we just look at how many ways can it happen out of how many ways did we do something. That's how we find experimental probabilities. Theoretical probabilities are a little bit different, is we look at how many ways can that happen out of the total outcomes in the sample space. So my sample space here is all of these things, the spot, the stall, and so forth. If I were going to try to use theoretical probabilities for this, then I would say the probability of getting a scratched lens, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different outcomes that can happen when we made the defects that we could have. And scratched is 1 out of those 13. So you would say, well, the probability of scratched would be 1 out of 13 if you did theoretical. However, I don't believe this number is 1 out of 13. In fact, I'm pretty sure it's not. If I wanted to, I could go calculate that. R actually will calculate probabilities things for you. So I could calculate that. If I took my if I took my 5,865 and divided it by my total of 25,891, I'm not going to get 1 out of 13. In fact, 1 out of 13 is definitely a different number. And so we want to know why did it not work in this case, but it did in the other case. So why could I do theoretical probabilities here and say it's 1 out of 6, but here I couldn't do it? And the reason is, and again, I'm going to kind of do more of a lecture this time, is because things have to be what we call equally likely. Equally likely means they have the exact same chance of happening. So with my eyeglasses, these different outcomes don't have the same chance of happening. A small or a scratched lens is way more likely to happen than a lost lenses, which is good. We hope lost doesn't happen very often, but scratched happens way more often. So they're not equally likely. So I can't just say it's 1 out of 13 because they're not equally likely. However, if my die is fair, I can do exactly what I was told. So this probability of getting a 1 is 1 divided by 6 because there's one way of getting a 1 out of 6 ways of getting anything. The probability of getting a 2 is also 1 out of 6. And so forth. All the rest of these are also 1 out of 6 because this is what we hope would be a fair die. The way I find out if it's a fair die is I actually try rolling the die and find out if it's a fair or not. And we'll do some dice next time. So these are all 1 out of 6 because there's one way each one can happen out of 6 ways anything can happen. So those are how we do theoretical probabilities. This is how I write my theoretical probabilities. This is how I write what I call the event space, which is how many ways can that event happen. But we're going to deal mostly with experimental probabilities in this class this semester. So here's another situation. So we have, according to the article, hip hop is turning on Donald Trump. Rappers love Trump's money, but not now they hate his politics. By Allison McCain. Many hip hop songs mention candidates who run for presidential election in 2016. Some of the comments were positive and some were negative. This data set contains that information. And again, what I want you to do is I want you to copy this data set. And I gave it to you down below. I hope I gave it to you. Did I forget to give it to you? Oh, no. Oh, it's in the 538 package. There we go. Okay. So this data set called hip hop _CAD _lyrics is in the 538 package. And so we're going to go ahead and do a tally command for this one. Again, tally commands will count up how many ways it can happen. So we're going to go into my RStudio and turn on that 538 package. So again, I come over here to packages. I find 538. Again, they're in alphabetical order. There's 538. And I want the data package one, just in case. I'm going to turn them both on because I'm not sure exactly where it is. So I'm just going to turn on both of them just by clicking the box next to them, and then they will turn on. So now they're active for me. I can actually do a help on the 538 data. And it would then show me what's in that package. It gives me the code book and so forth. So this is actually not the one I want because I don't want the data. I want, well, actually it says to list all the data sets, do this command. So we'll copy that command. We'll run that command. And there's all of my data sets that occur in here. And we are working with the one called hip hop that may actually not be in this one. I think it's actually in the other one. So we're going to go look at the other package. I'm just going to do help on the 538. And so let's do that. We'll do that one and do a help on that one. And hip hop should be in here. Well, flying is. Flying's on your homework, on your test. And there is the hip hop one. So here's the hip hop one that we want to look at. We can actually do a help on that one. So we can actually see what that actually says. So we can do help on the hip hop. And now it gives me my code book. So here's my code book on this. These are all the different things it has. It has the candidates referenced. It has the song title. It has the artist. It has the sentiment, whether it's positive or negative. It has the theme and so forth. So we're going to, again, do a nice little tally command on this. I'm going to close this out because we want to see a little bit more. I'm going to clean this so you can just see a little bit better what I'm typing. Again, I'm going to do the tally command. I gave it to you in this file. However, I can't copy from here. You can copy this. I can't copy this. It won't let me copy. But this is what I want to do is the same tally command. You just copy that from your PDF file, put it into your RStudio. I'm going to type mine in, and it's the tally command. I'm going to do candidate with sentiment. And then again, my data is equal to the hip hop and lyrics. And I actually like the margin equals true because I want to be able to see the totals. So when I did this way, and actually I did slightly different than I wanted to do. I want to actually keep the tilde here. I mean, this actually worked fine, but I'm gonna put the way I did in the notes. The tilde at the start and a plus in between. I want to take the candidate plus the sentiment. And it gives me the exact same piece that I got before. I just wanted to show you can do differently. So when I do this command, I now get all of this information. So we're going to go back over here into my notes. That's the last thing I need of the RStudio. I'm going to paste it here. And we won't need to use RStudio again. That just gave me this. Now everything else is just going to be reading this table that we just now created. All right. So what is the probability the song is about Donald Trump? And again, what we're going to assume is that this is the entire population. We selected a song at random. And what we're going to do is we're going to look for Donald Trump here. These are all the ways they have it. And there's my total. So there are 268 songs about Donald Trump. So when I go to do this probability about Donald Trump, oops, if I can type correctly, I see that we had 268 songs that were just about Donald Trump out of the 378 songs. So there's my probability, because that's all we have to do for probabilities is take this total for Donald Trump and divide by the total there was of all of the songs. So what's the probability the song has a negative sentiment? So you tell me, what was the probability that has a negative sentiment? You can either put in the chat or just unmute and tell me.
74 or
74?
34?
The 34
34
was just for Donald Trump. So this is just negative for Donald Trump. However, I asked for just negative sentiment. 71 out of how many? So whoops. So when we do these and we talk about this information, it is the probability is always out of something. It can't just be the 71. It's a 71 out of however many. So out of how many? So 71 out of how many songs?
377.
377. So all I did was I took this column total, the negative column total. Here's my negative, whoops, can't do that. Here's my negative column total, and I put it over my total. And you can see that there's here, this says total here. This one says total here. So this 377 is my total. All right. Obviously there are more songs about Donald Trump than there are about the negative sentiment. Because there's 268 out of 377 about Donald Trump and only 71 out of 377 about negative. I'm going to keep using the same thing. So now let's look at what probably the song is about Hillary Clinton. So again, I'm going to go back to my table. So now what's the probability that the song is about Hillary Clinton?
$92.
92? So my probability is 92? Is that all my probability is?
Over 377.
Yeah. So remember, don't forget to have the denominator because it can't just be 92. It's going to be 92 out of some number. All right. So let's keep doing this. Now let's look at the probability. It's about Ted Cruz. So what's the probability it's about Ted Cruz?
One out of 377.
Yeah. So obviously there weren't too many about Ted Cruz. So which one is more likely to have had a song about them? Ted Cruz, Clinton, or Trump?
Trump.
Trump, because his probability is much bigger than the other two. And obviously Ted Cruz is very, very small. One more. We're going to do actually lots more, but let's do another one here. Let's do the probability that it actually has a positive sentiment. So what's the probability it has a positive sentiment?
178 out of 377.
Yeah. So is it more likely that they're positive or negative? So looking at my negative one, which one's more likely, negative or positive?
Positive.
Yeah, positive is way more likely because the probability is higher. Again, I don't reduce these. I don't really make them into decimals. I just leave them as they are. All right. What's the probability the song is about Donald Trump and has a negative sentiment? So now let's talk about what the word and means in the English language. If I say somebody is if a song is Donald Trump and negative, what does that mean? What does that and mean?
It's included.
It's included? All right. So it means that, yeah, so it's included. It means that both things are happening. So now what's the probability that Donald Trump had what was the probability the song was about Donald Trump and it was a positive song? Does anybody have an idea of how to do that?
160 over 377.
Yeah, because if you look at this, here's my positive column, here's my Donald Trump row, and they intersect right here at the 160. So it's 160 out of my 377. Oh, because I wanted negative. That's right. I wanted negative. So now what's about negative?
$34 over 377.
Yeah, so now it'd be the 34 over 377. So, by the way, does it look like Donald Trump was had negative things against him more or positive things against for him? The rap songs, were they more positive or more negative?
Positive.
Positive.
More positive. Okay. All right, so this one is 34. 34 out of 377. Oops. All right. Now let's look at what's the probability the song is about Hillary Clinton and has a negative sentiment. So going back to my chart, so you're going to see this chart's very, very useful, very helpful here. So Hillary Clinton and negative.
$29
There's 29
out of 377.
at 377. All right. So does it look like Trump had more 29, whoops, had more negative songs than Hillary Clinton did? Was the probability higher that he would have more negative songs than Clinton would have?
Yes.
It is, but really 34 out of 377 and 29 out of 377, they're not going to be that different, are they? And in fact, if you want to know how different they are, you can use a calculator or use our studio to calculate that and see what it is. Since I don't have a calculator on me, I'll just over here and type it. So 34 out of 377. I can't type today. Is 0.09, and 29 out of 377 is 0.07. So yeah, it is a little bit higher that he had more than she did. Okay. Let's do some more questions. Let's find out the probability the song is about Ted Cruz and has a positive sentiment. So I'll go back to my chart, my table. So what's the probability of Ted Cruz and positives?
Zero.
Zero, yeah. And I'm going to go ahead with my 0 out of 377, but that is equal to 0. So, in other words, there were no songs that were positive about him. All right. So now what I want to know is, now we're going to do or. So or is a little different than and. So what does or mean in the English language?
It's like one or the other.
Yeah. So we either want Ted Cruz or we want positive or both, right? We could be both too. But we either want Ted Cruz or positive. Whereas and means both have to happen or means it's one or the other. So looking at this, there are positive songs. Is this one, we have this 160, this 0, this 16, all these zeros. So there's 178 songs that were positive. Ted Cruz, there was one song that was one song. So what would be the probability of positive or Ted Cruz?
179.
Yeah. 179 out of the 377. Don't forget the 377. Okay. So let's do the same thing with Donald Trump. I'd like to know what's the probability that Trump or negative. So I do use a symbol for probability, just a P, because I'm too lazy to write out probability, but you're more than welcome to just write the probability of Trump or negative. That's also fine. You don't need to use symbols. I just am too lazy not to. All right. So now let's look at Trump or negative. So we're going to have this negative, so that 0, this 1, this 0, this 34, this 29, this 5, this 1 is 1 and 1. So we have 71 songs that are negative. We have these 30 for Trump, we have these 34, but we already counted that 34, right? So I don't want to count that 34 again. So I've got the 71, which includes that 34. Then I've got this 74, this 160 also. So the probability for Donald Trump or negative would be the 71 that were negative plus this 74 and this 160. I don't want to cloud this 34 because then I'm counting them twice. So that would be my 71 plus my 160. What were the numbers? I forgot them already. See how fast I did that? 71, 74, and 160. There we go. And then that's still going to be at a 377. And so you could find out what this is, what 71 plus 74 plus 160 is. Again, you can either use the phone on your calculator or you can use our studio. I'm going to use our studio because I don't have my phone up. So I'm going to take and add up those numbers because I'm too lazy to add them up myself. 74 plus 160. And that adds up to 305. So this would be 305 out of 377. So that's pretty high to have either a song about Trump or a song that's negative, because that's pretty close to a lot of the songs.